Okay, this is going to be more fraction basics, and I'm going to talk about fractions with different numerators. Okay, so the top number is going to be different. So here's 1, here's a half. By the way, 1/2 and 1/2 are just two ways of writing the same thing. And you have to type it out horizontally like I did here. You use the slash instead of a horizontal bar. Okay, it means the same thing. So if I have 1/2, it means I have one thing and I divide it by 2, and that's literally what this means, 1 divided by 2, and it comes out like this. And so it's smaller than the original. In fact, it's twice as small, or in other words, it's half as big, is what it's it. What if I have more than one of these, though? Okay, I can just pop these into existence. So if I put two of them together, this would be 2/2. And notice that 2/2, when you put them together, is the same overall size as the original 1. The half tells you how many ways I divided it. I divided it into 2 pieces. And the 2 on top says how many of those pieces I have. And notice that if you just look at the numbers instead of looking at the pictures, there's something about these. I can divide both of the top and bottom by 2. Half of that is 1 and half of that is 1. And so 1/1 would be one whole thing. Okay, that's 1. So whenever you have the same number top and bottom, it means you're cutting it in half, but you're going to take 2 of them and you're right back where you started with the one whole thing. Okay? Okay, what if I have another half? So I'll now have 3/2. So this is getting beyond the original 1, isn't it? I'm not going to line them up perfectly there. So if I take 3/2, notice that's equivalent to the original 1 and half again. So this is the same as 1 and 1/2. This is called a mixed number, or some textbooks call it mixed numerals, or whatever. Different teachers would say it differently. But in other words, I have mixed notation here. I have whole number notation and I have fraction notation. They're just put side by side. What this really means is 1 plus 1/2. So I have the 1 here, and I have another half. All right? And so 1 and 1/2, you can read it like this, but what it really means is 1 plus a half. And it's important to know that because when I start working with these, when I'm adding fractions, this is like two different numbers here. It's like the 1, and there's also the half. So this is 1 plus a half. And if I add it to something else, I'm going to have another maybe whole number and another fraction. And I can just add them all up. Okay? When you have a fraction and the number on top is bigger than the number on the bottom, that means I have more than one whole thing. So I didn't get all those pieces from this one thing. I got it from maybe a bunch of copies of this. Think of this as a brick, and I got 2 of these halves from maybe this brick, but I also broke up some other bricks, and I have other halves sitting around. So if I string 3 of them together, this is equivalent to one whole brick and another half. And so that's how you get the 1 1/2. As soon as you have a fraction where the numerator is larger than the denominator, this is called an improper fraction. Okay, I like to tell my students there's nothing improper about an improper fraction. It's a perfectly good way to write a number as far as I'm concerned. In fact, when you get to algebra, this is going to be preferred over this. Mixed numbers are sort of messed up. In other words, you're mixing different kinds of notation here. Whereas here, it just means that divided by that. Okay? Or you take 1 over this and then multiply the result times 3. Basically, here's the size of the piece and here's how many of them you have. All right? Let's try a different fraction. Okay, here's a third. Notice this is 4 little squares from the graph paper, and this is 12, so that's a third of them. Okay? So this is 1/3. If I make copies of this, so here's another third. Let's pick it up and put it there. This would be 2/3. So this much, which is more than half, but is less than the whole, that's 2/3 of the original. Okay? If I have another one, This would make 3/3. And notice as soon as I get the top number equal to the bottom number, it's equal to 1. So 3/3 is equal to the original whole thing. I cut them in 3 pieces, but I ate all 3 pieces. If that's a chocolate bar, for instance, I ate all 3/3, you ate the whole thing. Okay? If you eat 2 halves, you've eaten the whole thing. If you eat 6/6, doesn't matter how many pieces you chop it up, it's not going to save you calories if you eat all 6 of them. Okay? So, again, I can go more than 1. What if I go 4/3? So here's another third, and this would be 4/3. And notice the top is bigger than the bottom, so now we have an improper fraction. It means I could write this as a mixed number. So how many of these thirds make the whole? Well, 3 of them, and then there's 1 left over. So if I divide 3 into 4, so you say 3 divided into 4 goes once, and there's 1 remainder. So that's 1, and then 1/3 left over. So this is how many thirds are left over after I've done the division. So I have 4 things. I say, how many 3's are there in here? Oh, there's only 1 3, and then there's 1/3 left over. So it comes out 1 whole plus 1/3. Okay. I said this is sort of a mixed up kind of a number because it's actually 2 things added together, but they're just written side by side. This means 1 plus 1/3. And you just write it as 1 1/3 this way. You read it as 1 and 1/3. Think of the and as telling you there's supposed to be a plus in there. Okay, 4/3, 1 1/3, same thing. This one is improper. In fact, I guess this one's called improper too, because you don't have a piece anymore, you have the whole thing. Here you have a whole thing plus some extra. These are called proper fractions. And proper fractions are where you have less than a whole thing. So the top number is going to be less than the bottom number. So you chop it up into some number of pieces, and you have several of those pieces, but not enough to add up to the whole thing. That would be a proper fraction. As soon as you go more than 1, you have an improper fraction. Or in fact, if it's equal to 1, that's, I think, called an improper fraction too. Okay, let's look at fourths. Okay, there's a fourth. Notice it's 3 squares long, and this is 12. 3 times 4 is 12. So 4 of these should make up one of these. Let's try it. Here's a second one. And notice that 2/4 is the same thing as 1/2. So if I compare this to a half, 2/4 is the same as 1/2. Now, in terms of the arithmetic here, you can recognize that, because look at this numerator and denominator. You can divide both of them by the same thing. So if I divide top and bottom both by 2, 2 divided by 2 is 1, 4 divided by 2 is 2, and so 2/4 reduces to 1/2. Let's put on another fourth here, and this would be 3/4. There's 3/4, and if I put down another one, here is 4/4, and notice that 4/4 is the same thing as 1. Okay, if I keep going, here's 5/4. That would be 5/4. You can tell that's bigger than 1 because the 5 is bigger than the 4. If the number on top is bigger than this, 4 of those would make up the whole, and you have 1 of them left over. So here's 4 of them makes up one whole thing, and you have 1/4 left over, 1 of them. Okay, so this would be 1 1/4. Okay, so if I do another one here, that's 6/4. Notice that 6/4, if I divide top and bottom by 2, half of this is 3, half of this is 2. So if I divide top and bottom by the same thing, this should equal 3 halves. Is it? Well, here's a second half, and here's a third half. And so 6/4 is the same as 3 halves. So that's something you can always do with fractions. If I start off with halves, if I multiply top and bottom by 2, I'm going to get 2/4. Okay, so 1/2 is the same as 2/4. What if I go 1/2 and multiply top and bottom by 3? This would be 3. 3 times 2 is 6. So we don't have sixths here yet, but you can expect that 1/2 would be the same as 3 of them. Okay, if this is 12 squares long, a sixth is going to be 2 squares long. So here's 2, 2, 2. So one of the things is if I have a fraction, I can multiply top and bottom by the same thing, and the overall fraction is equivalent to the original one. I haven't really changed the size of it. I just changed the size of the pieces, but I also changed how many of them I have. If I have twice as many pieces, and I take twice as many of them, I've taken the same overall amount. If I take 3 times as many pieces, but I take 3 times as many of them, I have the same overall amount. Okay? So the point of this exercise really is to get used to the idea, if you have a fraction, you can have pieces of any size, and this tells you the size of the piece. It's the denominator. If you abbreviate it, just say denom, period. Okay, denominator. And this thing on top is going to be telling you how many of them you're using. It's the numerator. If you abbreviate it, just say NUM. So you got your numerator and denominator, top number, bottom number. This is how many, this is how big they are, and that makes up your fractions. If you have less pieces than there are the number of pieces in a whole thing, you're going to have a fraction, a proper fraction, something less than 1. If this number on top is equal to the bottom, you have a bunch of pieces, but you have all the pieces together that makes up a whole thing. 3/3, 4/4, 5/5, 6/6, etc. That's going to be 1 in every case. If that's bigger than that, you have a 1 and then you have a few left over. The amount you have left over is going to be a fractional part. So you could say 1 and whatever fraction is left over, and you get that mixed number notation. Okay, that's about it for now. We're going to learn more in the other lessons that follow how to work with these. How do you add, subtract, multiply, and divide fractions, change fractions into mixed numbers, change mixed numbers into fractions, do all that kind of stuff. We want to become fluent so we can represent numbers using fractions.